Hi guys, Professor Burns here. We're going to look at section 4.4 in this lesson, and this is the last section where we're talking about regression equations and scatter plots. All we're going to do in this session is just look at how we evaluate how good our linear equation is, our linear model. How well does it predict the data? And so make sure your cell phones are put away and you've got your notes out and you're ready to listen for the next few minutes. This is a short video. So a few notes it starts off with, some cautionary notes about regression. Do not use, first of all, and we've talked about this, but I want to remind you again, do not use a linear model to describe a non-linear trend. So always look at that scatter plot first and make sure that it's actually a linear trend. And if it's not, we have to do something different. Don't try to force it to be a linear model when it's not. The second bullet point there says, association between two variables is not sufficient evidence to conclude a cause and effect relationship. So in other words, no causation. And this is a very important point. You've probably heard the phrase correlation does not mean causation. Just because two things are related to each other doesn't necessarily mean that one caused the other. So when we look at a scatter plot, we look at a linear regression, we don't ever want to say causation. That's why we always use phrases like there tends to be a positive trend or a decreasing trend or whatever. But never, ever, ever assume causation just because there's a strong correlation between the two variables. The next one, it says outliers can have a big effect on R. Always check for the outliers in your scatter plot. So just watch for outliers. Outliers really do make a difference. Remember, R you can kind of think of in the same way we used to think of standard deviation. It gives us an idea of how far apart our data is, how spread out it is. So the further apart those points are, remember, the worse the correlation. I shouldn't say worse, the lower the correlation. And when you have an outlier, that means those points are even farther apart, which lowers the correlation some more, or lowers that R value some more. So when you have an outlier, just be mindful of how that could affect that R value. Sometimes taking that outlier out will improve your correlation considerably. And so you always want to look for those when you look at the scatter plots. And then finally, do not make predictions beyond the range of data. There's a special name for this called extrapolation. So you want to avoid that. No extrapolation. Your model is only good for the range of data that you're given. Never go beyond the range of data. That's called extrapolating, and we don't want to do that when we're working with our linear equation. The next thing I want to talk about is the coefficient of determination. So we know what R is. R, of course, is that correlation coefficient. It gives us an idea of how closely correlated those variables are. The coefficient of determination is found by doing R squared. Literally, just take the R value and square it. This gives us an idea of how good our model is, how well our model fits the data. We usually write it as a percentage, so once you get that R squared value, you would make it into a percentage. It would be a decimal. You'd make it into a percentage between 0 and 100%. And it measures how much variation in the dependent variable is explained by the independent variable. So in other words, how much are those Y values in the model explained by the X values? Obviously, the higher that percentage, the higher the coefficient of determination, the better your model. That gives you an idea of how good your model is. R squared, the larger R squared is, the smaller the amount of variation or scatter is going to be in the regression line. So we're hoping for a larger R squared value to give us an idea of how good our model is. And we will do some practice looking at this coefficient of determination tomorrow in class. So make sure you bring your notes with you, and I'll see you then.